Welcome to episode 32, Choosing Google's AI and ML Options, where we learn how to select the most appropriate tools for solving real business problems. Google Cloud offers a spectrum of artificial intelligence and machine learning capabilities, from simple pre-trained application programming interfaces to custom-built models. The challenge is not technological abundance, but strategic alignment, choosing what fits your data, your goals, and your capacity to maintain it. Many teams leap toward custom solutions when an existing one would suffice. In this episode, we'll break down how to navigate the decision space by starting with the problem, assessing constraints, and following a progression from the simplest effective option to the most sophisticated when truly needed. Good AI strategy begins with restraint, not excess. Every AI journey starts with a clear understanding of the problem and its constraints. Before comparing products, define what decision or outcome you want to improve, who will use the result, and what limits, time, budget, or data apply. A precise problem statement acts like a compass. We want to classify support emails by urgency within 5 seconds is far more actionable than we want to use AI for customer service. Constraints reveal which tools are realistic. For instance, strict latency or regulatory rules might rule out certain architectures. By anchoring on purpose and limitations, you prevent technology from leading the conversation. The right solution grows from well-understood needs, not from curiosity alone. Pre-trained APIs are often the fastest path to results when your needs match common patterns. Google provides ready-to-use interfaces for vision, speech, translation, text analysis, and more. These APIs encapsulate years of research and massive datasets behind simple endpoints. For example, the Vision API can label images or detect objects without any model training. Using pre-trained APIs minimizes setup, cost, and risk because Google maintains the models and infrastructure. However, their power lies in appropriate scope. They excel at standardized tasks but cannot reflect company-specific language or unique workflows. When they meet your requirements as is, they deliver near-instant value. When they fall short, they still make an excellent baseline for prototypes and benchmarks. Custom models come into play when your challenge is novel or your competitive edge depends on proprietary insight. Building from scratch with TensorFlow, PyTorch, or other frameworks offers maximum flexibility but also maximum responsibility. You manage data pipelines, architecture choices, and continuous retraining. For example, a logistics company developing a route optimization algorithm might need a fully custom model to integrate live traffic, weather, and fuel constraints. Custom work makes sense when no packaged or automated tool can reach your required accuracy, or when intellectual property protection matters. However, it demands advanced skills, careful documentation, and ongoing maintenance. The hidden cost of customization is operational debt. Models that cannot be updated or explained often become liabilities rather than assets. Latency, throughput, and availability requirements shape architecture decisions. Latency measures how fast predictions must return. Throughput measures how many predictions per second you must serve. Availability defines how reliable the service must be. A chatbot requiring millisecond responses has different needs from an overnight forecasting job. Google Cloud offers hosting choices from online prediction endpoints for real-time workloads to batch processing for deferred tasks. For example, Vertex AI endpoints can auto-scale to meet variable traffic while keeping latency predictable. The misconception is that faster is always better. In reality, optimizing for ultra-low latency can inflate cost unnecessarily. Match service levels to business tolerance, not aspiration, and design redundancies proportionate to the consequence of downtime. Data volume, quality, and labeling capacity determine what level of ML maturity you can sustain. Large, clean, and balanced data sets enable stronger models, while noisy or sparse data often favors simpler approaches. For example, if you only have a few hundred labeled cases, classical algorithms or rules may outperform deep learning. Labeling quality is often the bottleneck. Unclear or inconsistent labels introduce bias that no algorithm can fix. Tools like Google's data labeling service or third-party annotation platforms can help, but they require clear definitions and review steps. Treat data as the product's foundation, profiling, cleaning, and versioning it continuously. Without this discipline, even the best tools yield unreliable predictions. Data readiness dictates model ambition more than technology does. Team skills and operational readiness are practical gatekeepers of success. A pre-trained API can be implemented by general developers. AutoML requires moderate data preparation and interpretation skills. Custom modeling demands data scientists, machine learning engineers, and MLOps specialists. Beyond expertise, readiness includes process maturity, version control for models, monitoring infrastructure, and escalation paths for incidents. For example, if no one on the team can debug a gradient descent failure or retrain a model safely, a simpler solution is wiser. Matching tool complexity to available skill prevents burnout and project stall. Training programs, clear ownership, and realistic staffing plans turn ambitious AI strategies into sustainable operations rather than fragile experiments. Cost balance between training and inference often separates affordable success from runaway expense. Training costs spike with data size and complexity, while inference costs accumulate over time as predictions scale. A model that is cheap to train but expensive to serve can quietly drain budgets. For instance, a real-time translation service may process millions of requests daily. Optimizing model size or caching frequent phrases can reduce cost dramatically. Google Cloud's pricing models allow per-query billing or reserved capacity to match usage patterns. The misconception is that cost equals value. In reality, efficient systems deliver the same outcome with fewer cycles. Build financial observability into your pipeline early so decision-makers see trade-offs clearly and tune usage before costs escalate. Privacy and compliance boundaries define what data can be used and where it can travel. Regulations like the General Data Protection Regulation, or GDPR, and industry standards such as HIPAA for healthcare impose strict controls. Before choosing a tool, confirm whether data must stay in certain regions, whether it contains personally identifiable information, and whether consent covers automated processing. Google Cloud offers encryption, access control, and regional storage options to support compliance. For example, healthcare projects can leverage de-identification and private endpoints to protect patient data. The misconception is that compliance is an afterthought. In reality, it is an architectural constraint. Designing privacy early avoids rework, reduces audit risk, and reinforces customer trust. Prototyping quickly and measuring early value prevent overinvestment in unproven directions. Rapid prototypes clarify feasibility, reveal hidden data issues, and create tangible learning. Google tools like Vertex AI Workbench or BigQuery ML allow teams to build proof-of-concept models directly in familiar environments without heavy setup. The goal is not perfection, but insight. Can the model predict meaningfully, and is that prediction useful enough to justify scaling? Early measurement also builds stakeholder confidence by showing real data-backed progress. A small working prototype communicates more than lengthy strategy documents, demonstrating whether the problem and solution align before deeper commitments are made. Planning the life cycle of retraining and monitoring ensures models stay effective after deployment. Every model decays as data drifts and behavior changes. Retraining schedules, versioning policies, and health dashboards keep performance visible. Google's Vertex AI provides pipelines for automated retraining, testing, and deployment to streamline this process. For example, a fraud detection model might retrain weekly using new transaction data while retaining previous versions for rollback. Monitoring should track accuracy, latency, cost, and fairness over time. The misconception is that launch marks success. Maintenance is where reliability is earned. Lifecycle planning turns machine learning from a one-time project into a continuous product that matures with its environment. A structured decision tree helps prioritize options. Start with the simplest tool that meets your requirement, then escalate only as necessary. Begin with pre-trained APIs for standardized needs, move to AutoML when proprietary data matters, and reserve custom models for cases demanding innovation or control. This progression saves effort and accelerates learning because each stage builds on the previous one. The danger of skipping straight to complexity is technical debt, overbuilt systems that exceed your current maturity. Following the simplest effective solution principle aligns investment with readiness, ensuring each step delivers tangible value while keeping future expansion open. Choosing the smallest effective solution is the mark of maturity in AI strategy. It balances ambition with stewardship, ensuring that technology serves outcomes rather than the other way around. When teams begin with the problem, test quickly, and scale responsibly, they capture benefits sooner and sustain them longer. Google's AI and ML offerings form a ladder, not a race. Each rung supports a different stage of capability. By climbing carefully, you gain confidence, build governance, and avoid waste. The reward is a portfolio of solutions that are not only intelligent, but also efficient, compliant, and trusted proof that smart choices matter as much as smart technology. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.